This module is called Production, Water Quality, and Public Health and Safety Aspects of Water Recycling. It's a general overview of water recycling, and it includes the elements about why we use recycled water, treatment of recycled water, the quality of the product, health and safety issues, treatment that brings out. I have the picture of 49ers training area. I've been using this for the past 18 years doing this program because they are one of the first users of recycled water on their athletic fields. And they are a very proud user, and we are proud of the fact that they have been a user of recycled water, very successful. And of course, our precious athletes who play on these fields have been doing just fine. So that's a great example to show other prospective customers of recycled water. Water recycling is really vital to the Bay Area. It is a resource that is compensating for the fact that the Department of Water Resources, DWR, projects really large statewide shortages of water for the future because, and I'll show you a graphic about how much those shortages are in quantitative numbers. Our traditional sources of water are basically tapped out. We have dammed all the rivers that we could have dammed. No longer can we do more of that. It's really difficult to get environmental clearance to do anymore. Treatment technology is there to produce any kind of water that we can produce. As you have seen from this brochure, we can take out everything out of the water except the molecules of H2O, which is really a very amazing thing that we can do now economically. And it's being done in many, many places for producing drinking water that actually can be recycled from wastewater. Someday we'll be doing that here in San Jose. Recycled water is a local water resource. We produce the raw material for it. So we are not at the mercy of somebody else to import the water from. It is economical. Counting all of its benefit is economical. That's why there are over 300 systems like South Bay Water Recycling. South Bay Water Recycling is one of many in the state that do this. And they have been doing it, they continue doing it, and they wouldn't be doing it if it were not economical. Recycled water is a reliable supply, even during drought. As long as we flush the toilets, there is a raw material to produce recycled water and serve it to the customers. Because of all these, recycled water is vital to the Bay Area. Look at these pictures of Lake Mead, for example, with a huge bathtub ring. This is about 150 feet thick. That water used to be up here. It's down there, and it's going down even further. It's been in a long-term drought. Lake Shasta, same situation. Some other pictures. I mentioned the Department of Water Resources projections of water shortage in the future. This is the graphic I promised you. In the year 2000, this was our shortages, about 3 million acre-feet per year in normal years, going up to drought conditions of having 8-9 million acre-feet per year of shortage, of deficit. An acre-foot of water is a lot of water. It's about 326,000 gallons. So millions of that, 3 millions of that unit are incredible. An acre-foot can supply 2 families in a year, 3 families in some places. So as the years go by, it gets worse. 2010, 2020, these are projections. I don't have 2030 projections, but if we don't do anything about it, it gets worse every year because our population keeps increasing. Our demand for water keeps increasing, and yet our supplies are relatively constant. So how do we make up for this deficit? There are several things that we can do for the deficit. Department of Water Resources, again, projects doing all of these activities in order to make up for those deficits. You can read them for yourself. These are all very big projects, and each one of them has some yield that can help make up the deficit in future years. And water recycling is a major one of those. And it can make up almost 1.5 million acre-feet per year by the year 2030. That's about half of that normal year deficit of 3 million acre-feet per year that I mentioned. It's quite significant, isn't it? It's a big part of making up our shortfalls. And you should be proud to be part of this system of making up for the deficits in water for our future generations. What is recycled water? It begins with drinking water. As we drink the water, as we use it for washing, for cooking, for showering, what have you, at homes, businesses, and industries, it becomes wastewater immediately. It's taken into the sewer lines, and it's taken away, takes all the dirt and the microbes with it, and it goes into a central treatment plant. In this case, it goes to the San Jose, Santa Clara Joint Wastewater Treatment Facility at the end of Zanker Road. I would invite you to arrange for a tour of the plant. It's a very nice, modern, high-tech treatment facility that produces excellent quality water, and adjoining it is this Silicon Valley water purification system that goes even further and produces even purer water to blend with your recycled water. So it's a good tour to take. Treated wastewater was historically discharged to the San Francisco Bay at the very bottom. Because of environmental concerns, the water recycling program was initiated to reduce the amount of discharge. But fortunately, it has become a big water resource for us as a result. So it served two purposes. Some of it's now becoming recycled water, and it's used in parks, golf courses, and other places for reuse. Globally, recycled water has been used in Europe for many, many centuries. In fact, in the olden days, in the Dark Ages, they used to use raw sewage for irrigation, and as a result, they had calamitous diseases, the Black Plague, the cholera epidemics that killed millions of people in Europe was a result of bad water recycling, not the right kind of recycling that we do, with a heavy amount of treatment, with monitoring and controls. They were doing it. They didn't know any better. They didn't even know about the role of microbes in transmitting disease to people. That came later with science improving and our knowledge of sanitary engineering improving over the years. So today, the Europeans are doing water recycling very much the way we do. France, Germany, especially this southern part of Europe, like Spain, Greece, Italy, are big users of recycled water. Japan, you would think, is a very wet country. They get a lot of water from the sky. But because their infrastructure is so condensed, so dense populations, they have to reuse wastewater so as to limit amount of discharge, because no longer can they put in more sewer lines. So they use as much water recycling for irrigation, for toilet flushing, for landscaping, all kinds of other purposes as we do practically. In the United States, there are several states that are big on water recycling. Florida is first, even bigger than us in terms of acre feet per year. Then California, Texas, Arizona, and a few other states. In Latin American countries, there's a lot of not so high-tech water recycling, unfortunately, because of economic conditions. That's why disease transmission is rampant in some parts of Latin American countries. Namibia is a country in southern part of Africa that is unique in that for the last 45 years, they've been recycling water for drinking purposes. Their drought and water shortage situation is so bad that 45 years ago, they decided to use this resource to its ultimate. So they have a very sophisticated treatment system. And last October, I was lucky to go there for the first time and attend the conference on water recycling that was held in Windhoek, the capital city of Namibia. And we saw the plant, we saw the treatment system, we drank the water, and I'm here to tell about it. Singapore also has been doing a great deal of potable drinking water recycling in the last few years, based on the experience from Namibia and other places. South Africa is big on water recycling. Australia had an 11-year drought, during which they ramped up their water recycling program very, very quickly, very rapidly. And very sophisticated systems and very sophisticated regulations. The regulations are based on risk. And for each use, they've got a risk level determination, and they do a very thorough analysis before they permit a water recycling system. The Middle East is a very dry portion of the world, and places like Saudi Arabia, Kuwait, they basically don't get any water in terms of millimeters per year. I mean, that's unimaginable how low the amount of water is that comes down there. So all of their water supply for their expanding population comes from the ocean, from the sea, seawater desalination, which is very expensive, very energy intensive, very difficult to do. But they do it because they've got the oil, they've got the energy, comes out of the ground practically free for them. So they have been doing water desalination, seawater desalination all these years. And now they realize that this water is too precious to dump after one use. So they are doing water recycling, very similar to what we do in California. They've learned from our techniques, our regulations, our standards, and they're doing a fairly good job. I've been there many times as a consultant, and I can tell you that it's safer to drink water in Saudi Arabia than it is in Mexico or Chile or any Latin American countries. The history of water recycling in California started in the late 50s, early 1960s with the advent of what we call Title 22. It's a part of our administrative code in California that deals with water recycling. In fact, it's called Water Recycling Criteria. It establishes the guidelines for use of recycled water, for designing the facilities, the distribution systems. This training program that we do today, it's all part of Title 22 and Title 17 of the California Code. We'll go into more detail about laws and regulations later, but that's how things started, by the advent of Title 22. Today, we have got not 250, but over 300 systems. I should update that in California. South Bay Water Recycling is one of 300. We do a lot of water recycling in California. There are over 5,000 sites using recycled water, this being one of the sites. The Levi's facility is one of the 5,000 sites in California that uses recycled water, and they use it here, as you saw earlier, in toilet flushing, irrigating the grounds, all kinds of different uses. And if one of the 49ers staff is here, they can tell you even more about what they do with recycled water. Brent is not here, is he? So the amount of water that we use with recycling in California now is 700,000 acre-feet per year, more than 500,000 acre-feet per year. So we're getting to that number, 1.5 million acre-feet per year for 2030. We're ramping up to that. We hope to get there by 2030 and make up for some of the deficits. The state policy is to increase water recycling by 1 million acre-feet per year by the year 2020 and by 2 million acre-feet per year, in addition to the 700 that we do now, by the year 2030. 43 specific uses are allowed. That covers nearly all potable, non-potable uses with recycled water. Just about anything you can think of is allowed. From sewage to recycled water, what is the magic to get us from sewage, from that nasty, awful stuff that stinks, to drinking water or to water that can be used for irrigation? The magic is treatment. And treatment happens in a treatment plant, in a treatment system that takes care of that. Raw sewage contains pathogens, and pathogens are disease agents, things that make us sick. A small glass of sewage would contain millions, if not billions, of microorganisms, viruses, bacteria, protozoans, things that can make us sick. And if you are exposed to a sufficient number of those pathogens, we get an infection. An infection doesn't really necessarily make us sick, because we have an immune system that fights it. And sometimes we succeed, but not always. Sometimes they win, and the immune system is overwhelmed, especially if our immune system is compromised. If we are sick, if we are immune compromised for whatever reason. Little children, babies, are immune compromised. Older people are immune compromised. People with HIV are immune compromised. And when that happens, the moment you're exposed to pathogens, you get sick. And that sickness could cause death. So we want to eliminate exposure to sewage. That's why our sewer lines are buried. That's why as soon as water goes down the drain, you don't see it anymore until it gets to the treatment plant, and there it's taken care of by professionals, by systems that have been designed to take care of it properly. Lack of immunity increases the possibility of disease, complications, and so on. Therefore, treatment and redundancy of treatment and reliability of treatment are extremely important, because we want to make sure that every gallon of water that comes out of that treatment system is as safe as the previous gallon and as safe as the next gallon. We are not aiming for an average safety. We want a continuous safety without fail. And that's why we have to have redundancy and reliability of treatment. And those redundancies are built into the system by law. Title 22 requires redundancy and backup systems, and making sure that if the end product is somehow off spec, it does not go into the distribution system. It gets shunted back into storage or back to the beginning of the treatment system to make sure that bad water doesn't go out. Recycled water is not wastewater. We used to call this whole process of water reuse wastewater reclamation. That word wastewater is stuck with water reclamation, and that was bad. And that's why legislators decided in the 1970s to change the terminology and just call it recycled water. The word recycling has a good positive image in the public's mind, and it is water. After it comes out, water is water. If I had brought 2 jars here, one of recycled water and one of potable water, you wouldn't be able to distinguish by color, by taste, by smell. They would be identical. The only difference is those tiny concentrations of organic compounds. We call them microconstituents or constituents of emerging concern at extremely low concentrations, very low. We can measure them, but they are not really relevant when it comes to irrigation or industrial use. The treatment technologies that are used to make the magic happen include sedimentation, biological treatment, clarification after biological treatment, filtration step, sometimes activated carbon in some agencies, but not all. And sometimes, if you want to go farther, microfiltration, ultrafiltration, nanofiltration, reverse osmosis, advanced oxidation, and other treatments added to take out more and more minute concentrations of various chemicals. And finally, at the last step, in all cases, is disinfection. Disinfection takes care of any viruses that might have escaped all these other processes. You pile up all these processes, and still some viruses might come through. So that's where we hit them with chlorine, with ozone, or with ultraviolet light and kill them. They are exposed at that point. There are no places for them to hide. And chlorine usually is a very good disinfectant, and it's used in solid water recycling and takes care of any remaining pathogens that might be there. So recycled water, at the end of this process, is not wastewater. It is a product that is safe and good. This is an image from a portion of the treatment plant at the end of Zanker Road. And again, as I said, it's a good place to go visit. This picture shows that biological treatment step that I mentioned. After sedimentation, it goes through biological treatment. This is where we supply air, in some cases oxygen, from the bottom of the tank. So the air becomes mixed up with the water, and that provides the microbes with the oxygen that they need to thrive, to survive, to keep reproducing themselves, and to eat up the organic matter. The organic matter, which is our waste product, is their food. They eat that up, it becomes part of their bodies die off, fall off to the bottom, becomes sludge. Sludge is taken away and buried. So what remains is water that doesn't include the organic nasty stuff that was there in the first place. So that's a very important step. It's almost every plant includes that step because it's so efficient at removing organic matter. Then filtration step, it looks like a swimming pool, but what's underneath the water is a layer of sand about this thick, 4 or 5 feet thick. Fine sand through which it gradually, slowly goes, and as it goes through that sand filter, it leaves behind any suspended particles, including bacteria and not viruses necessarily. Viruses don't get caught, but protozoans, bacteria, and so on get caught. This disinfection step looks like this. It's a serpentine path through which the water flows very slowly. It's supposed to provide, by law, at least 90 minutes of contact between the water and the chlorine so that a complete kill is accomplished. And we know that we have accomplished that if our daily measurement indicates less than 2.2 total coliform per 100 ml of water coming out. That's a standard that is pretty universal for the kind of uses that we're talking about here that are very close to human contact. At the end, we get disinfected tertiary recycled water, which is the kind of water that you get in your site. It's clear, you can see through it, and the foaming is because of the chlorine off-gassing as it falls off the weir. What does treatment accomplish? The treatment system accomplishes different things. Each of those steps does something different, and they are all vital. The sedimentation step removes solids and heavy metals and larger particles and floating stuff that comes in at the beginning of the treatment system. The biological treatment removes the organics. As I said, the organics are eaten up by the microbes. It's their food. So that's how we get rid of the organic matter. The clarification step removes the suspended particles. The filtration step, any tiny particles that are still left after the sedimentation step, after the clarification step, are removed in the filters and clarified. And finally, the disinfection step actually kills, by oxidation, it kills the microorganisms that are remaining, especially viruses that might survive. So, again, I repeat, recycled water is not wastewater and is got no relation to it anymore. The treatment process is shown graphically in this picture. Wastewater comes from businesses and homes. Primary treatment, where the heavy stuff gradually falls down. Looks pretty yucky, doesn't it? The secondary treatment, where microbes are working very hard, eating up the organic matter. So after that yucky stuff is not there anymore. The tertiary treatment is the final step of filtration. Water, sand, almost pure water at the end, coming out, ready to be used in sprinkler systems, and kids can play in it, no problem. So treatment is really the magic that produces what you're looking for. And we call that first step primary treatment, the second step secondary treatment, and we call that last step disinfected tertiary treatment. And I have highlighted that because that is what you get. These are the kinds of recycled water that are used for non-potable uses. All the 43 uses that they enumerated earlier. There's also what's called potable recycled water. For that, you have to have reverse osmosis, advanced oxidation, and a lot more monitoring and careful processing. And it's coming. Stay tuned. In the next 5-10 years, we will probably have potable recycled water in many places in California, possibly here in San Jose as well. And then there's another thing, gray water. Gray water is not recycled water. Gray water is untreated, non-toilet wastewater. It's still wastewater. It still could contain pathogens. Somebody could have showered who was ill, and some of the microbes got into the water. And some people have the habit of doing certain things in the shower that you're supposed to do in the toilet. So gray water is not necessarily free from fecal matter. But it's allowed to be used as long as it's discharged 2 inches below the soil surface. And there's a whole set of regulations for doing that. But we're not going to go into that. That's not your topic here. However, as the recycled water experts, you need to have that context. Know that gray water is not recycled water. Gray water is governed by the Chapter 16A of the Plumbing Code, and for washing machines, effluent, you don't even need a permit. As long as you comply with 12 specific conditions that are listed in Chapter 16A, you can have a gray water system based on washing machines in your home, no problem. If you want a more complex system, then you got to get a permit. And as I said, the emitters have got to be at least 2 inches below the soil surface with a mulch. And the reason for that is to prevent exposure. Again, exposure to microbes is what can cause infection and eventually disease. So if we limit exposure, if we eliminate exposure, we're good. Gray water is not recycled water. Here's a Japanese-style gray water system in which the wash basin for hand washing is built on top of the toilet reservoir so that the wash water goes in there and serves as the flush for the next flush, double use of the same water. It's very common in Japan. I've seen it in many homes and businesses all over Japan, and in some Australian places too, but in America, we are not allowed to do that yet. Here's a mental picture of the quality of water as it goes through various stages of use and treatment. We get water from various sources, from rivers, from wells, and what have you, and then treat it to make it potable. Potable water versus raw water. Raw water comes from nature. Potable water is what comes out of water treatment systems. Your water supplier, your water provider, San Jose Water Company, for example, treat that water that they get from nature and then supply it to at a very high quality level, a high quality level that meets Safe Drinking Water Act regulations, and it's very well controlled. As soon as we use that water, it becomes wastewater immediately. As soon as we take a shower with it, as soon as we wash our hands, it becomes wastewater, goes down to the toilet, and its quality drops from very high to extremely low quality. Now, this is not a quantitative measure of quality. I'm just talking qualitatively here. The quality of this water is, whether it's just wash water or toilet water, it's very, very low. It's unacceptable. But we give it treatment. Primary treatment improves it just a little bit. Then we give it secondary treatment. Makes it even better. That's why some uses are allowed with secondary effluent, but not here in San Jose. San Jose, we only have tertiary. Tertiary is where we bring the quality of water fairly high, very close, but not quite to the level of potable. Okay? Then we can add additional treatment, advanced treatment systems, and make it even better than potable water that we get today. And those qualities are comparable. Then gray water is somewhere here between primary and secondary effluent quality, but it is way down here low, so it's not good enough to be exposed to. That's why we have to use it at least 2 inches below the soil surface. So these lines show you the comparison between where we are with these different qualities. Another mental picture I have for you is in this graphic, where we show different uses, different treatments, and different risk levels. Irrigating orchards, the risk can be reduced very quickly with the secondary effluent. That's why it's allowed to be used for orchards. For irrigation of cemeteries, parks, and schools, where there's a lot of more intimate exposure, we got to go to disinfected tertiary before the risk level is reduced low enough that it's acceptable risk. For industrial cooling, the same. For irrigation of vegetables, the same. We got to get to that disinfected tertiary. But if we want to go to potable reuse, which someday we will, then we have to go even farther. Reverse osmosis, advanced oxidation. Reliability of treatment. As I mentioned, reliability is extremely important, and we have to have multiple barriers in order to have reliability. These multiple barriers are in treatment, in disinfection, site controls, especially with lower levels of treatment, Cross-connection controls, you'll hear about that next, in the next module from Mike. Backflow prevention, training and management. This training that we are doing now is a part of that various belts and suspenders that we have in order to make sure that water recycling is safe. Reporting of problems and violations is another thing that we do to make sure that reliability is accomplished. Okay, currently we have over 700 customers, and the way that historically the amount of water recycling in million gallons per day has changed is like this from 2000 to 2013. As you see, seasonally it goes up and down, up and down, up and down, but the trend has been upward. So we are increasing our amount of recycled water served to the community very rapidly. The recycled water uses allowed in California, there are 43 allowed uses. We talked about irrigation of all crops, including vegetables, but landscaping, golf courses, cooling towers, impoundments, which means swimming and wading. That's a very intimate use of a recycled water, which could include gulping. Toilet flushing, car washes, groundwater recharge. These are some landscapes that are irrigated with recycled water. Some examples, I already mentioned the 49ers field, Great America across the street from here. Silver Creek Country Club, Oak Hill Memorial Park, Rivermark in Santa Clara. It's the residential area. It's a very fancy new residential area. All the common grounds are irrigated with recycled water. In the future, we'll have more industrial, more landscaping, and expect to have some agricultural irrigation as well. In summary, tertiary recycled water is as safe as any other source of water for intended uses. This has been shown in various experiments in various parts of the state, and there's a good demonstration garden at the corner of Taylor and Spring that I would advise you to look at sometime when you're in the area. A couple of hundred different species of landscape material are grown there with recycled water very successfully. It's a good demonstration to look at. There's a CD that's produced by the University of California about management of salinity of recycled water. Use of recycled water is endorsed by the Department of Public Health, Water Resources Control Board, Department of Water Resources, various county environmental health officers, and these are very conservative guys. These county environmental health officers would not allow you to do something that's risky, but they are endorsing it. U.S. Bureau of Reclamation, U.S. Environmental Protection Agency, and the task force appointed by the California legislature. This declaration of support I showed you earlier, part of your packet, I would advise you to put it on your bulletin board and show it to anyone who might ask about the safety of recycled water. All these conservative agencies agree to it. It's also endorsed by various medical associations. We're very proud of their endorsements. There's been no known health cases from recycled water, no legal liability. It's as safe as any other source of water for irrigation.